Okay, list all the possible rational zeros of x squared minus x cubed plus 7x squared minus 9x minus 18. So we'll use the rational zero theorem. Again, we'll list all the roots of p over q, where p are factors of the constant term, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. And that's all over q, which are coefficients of the leading, or factors of the leading coefficient, which is plus or minus 1. So all the zeros are just the factors of the coefficient, or of p. So we'll use the graph then. When we look at the graph here, we can see that the zeros of the polynomial looks like it goes through 2 and negative 1. So we know if we synthetically divide by negative 1 and 2, those should work. So I'll start off by doing negative 1 first. So again, I'll synthetically divide by negative 1. I'm just writing the coefficients of my polynomial down. And we'll synthetically divide. Drop the 1. Negative 1 times 1 is negative 1. If we add, we get negative 2. Negative 1 times negative 2 is 2. And then we add the column, we get 9. Negative 1 times 9 is negative 9, and we add the column, we get negative 18. And negative 1 times negative 18 is positive 18, and when we add the column, we get the remainder of 0, which is what we thought. So again, we'll just continue dividing by the other 0 of 2. So we'll take the remaining polynomial and divide it by 2. Again, we'll just synthetically divide, or just continue down. We'll drop the 1. 2 times 1 is 2, and when we add the column, we get 0. 2 times 0 is 0. We have 9. 2 times 9 is 18. And again, we get a remainder of 0, which is what we expected. Now, the remaining polynomial is a second degree polynomial. Remember, we started out with the fourth degree. When we do this, this would be the fourth degree polynomial. Then we get a third degree polynomial. We reduce it by 1. And this is a second degree polynomial when we're done. So our remaining polynomial is x squared plus 0x plus 9, and if we set that equal to 0 and solve, we'll get the remaining two factors. So this is, I'm going to use the square root property to solve this. I'll just solve it for x squared, that's negative 9, and then the square root property, we'll take the square root of each side. We get x equals plus or minus the square root of negative 9, and the square root of negative 9 would be plus or minus 3i. So the four zeros that we get are negative 1, and 2, which we got from the graph, and then plus or minus 3i by factoring the remaining polynomial.